Hi there, in this tutorial I'll demonstrate how to create a chain that you can do things like this with. So you can see there's a number of chain links and they're physically linked together. This is a rigid body physics simulation and I'm just using some simple methods to animate the chains. You can see from above here how that's working. They're relatively horizontal but they're held taut at one end, so that allows me to move the other end and cause them to flip around. And here you can see the chains just being dropped and you can see how they are physically linked together. That's exactly the same simulation method as the previous one. And here I'm pulling a chain through another physical object and you can see how that's working. So a little word of warning about physics simulations like this, where particularly you have a lot of simulation going on, there will be a tendency for Blender to crash. This is still an area that's clearly got a few little issues. I don't know that it's any worse than earlier versions of Blender, but there are still some tendencies for either the simulation to break, which is much more common, or occasionally even for Blender to crash, especially if you start to have as many chains as I had in that example. So to begin with, let's create some chain links. So there's lots of different ways to do this, but we'll start with a curved circle and we'll go into edit mode. All of the 4 sections should be selected already, and then we can just right click and say subdivide. We want a few more than we originally had. At this point, I'm going to select those 2 and scale, bring those into about there. Then we'll select these 4, scale on X, and bring those to around there, and perhaps scale on Y a little as well, and we can push those out slightly now just to get the general shape that you want. Obviously there's other ways to do this, and then we'll go to curve properties under geometry and we'll go to depth of the bevel and we'll start to increase that. You will want to apply scale if you have rescaled it. I didn't, so it's not a problem, and we just need to get the thickness of chain link that we're looking for, and if we still need to adjust slightly just to clean that up, we can. Once you're happy with your chain link, we can right click it and say convert to mesh. And as just a quick material, I had a base color which was slightly blue. This is obviously the principled shader, the default shader that you get. I put metallic up at about 0.85, so mostly a metallic shader. I had roughness quite low at 0.095, and I put anisotropic up to about 0.175. And that's the extent of my shader. I also did this in Eevee just because it's obviously a lot faster to render. So we can preview that, but we've got no lights in the scene yet. So here's a little thing. Let's just set the background to black, and we can very quickly just add quick 3-point lights. Now by default, they will follow your object. That's the way they're set up to begin with. If you don't want them to do that, just go into properties, select each of the lights and either press that little I to stop the constraint working, or just press the X there. So I'm just removing the constraint from each of the lights, but they do need to be reoriented because we want them roughly converging. That's just very quick 3-point lights. You'll generally find they're not bright enough. And there you can see, if I select each light and start to turn it up, this is a fill light, so I'll make this quite a bit bigger anyway. And the key light normally very high brightness. Okay, what we'll also want to do is just enable under scene properties, turn on screen space reflections, and you can see that starts to improve the look of this a little bit. Just turn metallic up slightly, and perhaps we'll go down a little bit on roughness. So that will do for the moment. How much you see this as a metal object will depend on the surroundings as well. And you can obviously add an HDRI. So there's our link. So we'll just name that link 1, and we'll put this in a new collection which we'll call chain links, just to make things easier. We'll also put our lamps in a lights collection so that we can easily just turn those off and get them out of the way if we want to. So at this point we need to make a duplicate. Again, several different ways of doing this, but I'm just going to press Shift D and then GY, move it to somewhere about there and rotate Y 90. So we've got our basic chain link there. I've left them slightly separated, and I'm actually going to create another one. I'm going to Shift D on that chain link and GY and put that one about there. You can see I've got snap on at the moment. The reason I've created 3 is because this first one is going to be slightly different to the others. I'm going to select all 3, ending with this one on the right, which is chain link 1. Come down to physics and we'll say rigid body. I'm going to change the mass. Let's set that to 0.1 of a kilogram. Then I'm going to press F3 and say copy, and at the bottom you can say object rigid body copy from active. You can do that under the menu as well. So if we now select each one, they've all got the same rigid body options. We may not want convex hull because that may not fully define the shape that we have here. But that said, we're not actually relying on the mesh itself to give us the chain link. I'm going to get into that a bit more in a moment, but let's just select this first one and change this from active to passive. And I'm also going to select animated, but I'll explain what that's about later. But what if I press play now? You can see they just go flying off. So we can try changing to mesh. So I've just changed this one to mesh at the moment, and I'll change this one to mesh as well. And that sort of works. You can see it has connected. So you could try to make a chain that way. You just make sure you set it to mesh, and they are linked. The problem though is that that's quite a lot of work for Blender to do. I can set this one to mesh as well. And there's a lot more calculations to do. That said, it is working. You'll often find when you start to have a lot more links that just relying on that method is a problem. It also, of course, increases the workload for Blender. I'm going to leave it at mesh for a minute, but I'm now going to select all three of these, press F3 and say connect. And you notice it comes up with Object, Rigid Body, Connect. Again, you can find that in the menu. I've selected that, and you'll now see we've got what appear to be little empties appeared. And if I say move this around, you can see this one has a connecting line to that empty, and this one has a connecting line to both, and that's not actually right. So noting what these are, that's actually our first link. So we'll change the name of this one to main link, and then we've got link, we'll change this one to .001 for simplicity. We've got link 1 and link 2. So if we select our first link, again, if I press play now, nothing is happening. And part of the reason is because of the form of these links. I'm going to move that link to somewhere like this. So that link is the link for these two chain links, and that connector is the link for these two chain links. So this is chain link main link, which is our passive one, and link 1, or link 1.001. So we'll select that object, and you notice under physics settings, it tells you what objects it's linking. So we've already said that's link 1.001, so that would be wrong. Whether it's first or second, I'm not too worried, but that needs to be link 001 and main link. If I move it now, you can see that's what it's doing. It's connecting between these two. If I select this one, we can see that this is linking link 1 and link 2. So that's correct. However, you'll notice by default, the constraint is a fixed constraint, and we want these to pivot. So there are a number of different kinds of pivot that you can select from, but the one that worked for me most easily and will often work is point. So this just allows a flex in any direction. So let's press play now, and you can see that's working fine. So using connectors like this, it's not going to be perfectly realistic unless you take away the connectors and just use the mesh linking, because these links won't slide up and down each other very well. But for the most part, this is not noticeable. And what it does do is give you a much more usable simulation. You can enable collisions. Currently that's disabled by default. What that means is one object can pass through another while it's pivoting. So if I disable collisions for this connector, you can see it now no longer allows that link to pass through the other. But you can see already we're starting to get a bit of instability. There are occasions when you might want to do that and others where you wouldn't. But for a more natural chain link, disable that. You may need to play around with the relative position of the chain link and your connecting points in order to get a nice free swing. As I said before, if you want a completely realistic representation, you don't use these connectors, but you will run into problems when you start to get a chain link of 20, 30, 40 or more links. It will be very difficult to keep that chain in one piece. And as I said, it doesn't really show once you've got a lot of chain links going on. So it depends what you're going to use it for. If you just want a few links, then maybe just use the basic physics simulation as I demonstrated before I put these connectors on. So once you've got the basic chain started, so we can select these two and this link, and we can duplicate. Again, various different ways of doing this. So you can use Shift R to just repeat that. I won't do it too many times. There's a basic chain link there. But one of the problems of just doing it with Shift R is the way that each of these connectors is going to work. Whereas if you select larger and larger pieces of the chain, so if I was going to make another chunk of chain, I would select all of that, Shift D and then GY there, and take that up there. I'll delete that now. All of those connectors will be valid and connecting to the right thing. Whereas if we look at these, you can see none of these are quite what you expect. Well, so that one's okay, but that one you can see is not connected to the right things. So let's just delete most of these. So we'll copy that, GY, take that to about there. Correct the error in the linking. So this link is link 2 and this link is link 3. So here this should be linking between link 2 and link 3. We just press play. We can see that's now working fairly well, and again you don't really notice that they're not sliding up and down each other. So now what we can do is select all of those, Shift D, G, Y. We need to correct this one because that was at the head. So we've got link 4 and 5, so that should be link 4. And now if we press play, all of that works, and we'll do it once more. So we'll grab all of those plus that, Shift D, G, Y, select that one. It's going to be link 8 and 9. Select that one and just change this one to link 8. And now we should have a reasonably long chain that works pretty much as you would expect. Now you will notice that the connectors stay where they are. But that doesn't matter at all. So there's initially how to create just a free falling chain being held up by this one here. If I made this one an active object, this whole chain would just fall down together and it wouldn't look much like a chain. So at this point, let's add a plane. We'll apply the scale and lower it a little bit, and we'll go to the rigid body world and we'll make this part of the rigid body world and set it to passive. And you can see the chain is now falling down to that plane and resting there. If I go to here, we can see it a little better. So we can now see we're starting to get a chain, but we can also see there's a problem, and that is that the chains are passing through each other. You can see they've collapsed in a very odd way there. So what we should have done to correct that, and I wanted really just to show you the problem before I corrected it, is under here, for each of the constraints, we need to say disable collisions. So we just need to select each of our constraints and just disable collisions, or more specifically, enable collisions. Now you can see the chain can't pass through itself, but you can also see it's taking a little longer to calculate and it's not quite as stable. Got a little bit of jiggling going on there, and there's ways we can deal with that. So that's our basic chain link created, and now anything else you want to do is just based on what you do to control that chain. So for example, let's make a use of the default cube. I should say one of the things to be aware of when you're creating physics simulations is to make sure that you apply scale, because if you don't, you can get some unexpected results. So let's just put this cube here, make it a little bigger in that axis, and make it a little different color just so it's easier to see. And then what we'll do is we'll try and drag that chain over that cube. So the first thing we need to do is go to the physics properties and make the cube part of the rigid body system. Just apply the scale on that cube, and we'll make the cube a physical object by selecting rigid body. This is going to be a passive object, so it's not going to move around and it's not going to do anything other than be an obstacle. Let's just lower it a little bit, and then we'll select here. So I'm going to say I for location of that first chain link. And if you remember, that's a passive object. It doesn't move on its own. We'd already selected animated. If I didn't select animated, but I then animated it, this would be a problem. In fact, I'll do that now. So I've pressed I to set a keyframe for its first location. We'll go to frame 150 and we'll move it to somewhere like here and press I for location again. So we'll go back to the beginning and we'll press play. And you can see, because I haven't selected animated, the physics simulation is unaware that this object has moved. So I'll select animated now and try again. You can now see that's pulling the chain along. Now this is working at the moment, but you can very easily get some instabilities occur and have problems. So one of the problems can be that chain links can break and so on. So let that finish moving. And there we go. And once it's baked once, we can play it through fairly quickly again. And you can see there it goes. If you wanted to have some continuous movement, I'll just come to this keyframe and Alt-I and delete that keyframe. So if we go back now, that's no longer moving. And I'm going to select this object, which has got a single keyframe for its current location, and just do what I did with it before, which is go to the graph editor. I'll select the Z location, bring up the right-hand menu with N, and we'll say add a built-in function, which by default is a sine wave. It'll be much too fast to start with, so we'll try 0.1 for the speed. You can see that's just moving up and down a little bit. We'll give it an offset just to bring it back up to somewhere around where it was. Don't worry too much about what the simulation is doing at the moment. Give it a slightly higher amplitude, and I think we need to make it a little bit slower than that, so we'll go for 0.05. So at the moment that's just using a sine wave to drag the chain up and down. And what we can do is just click here to say copy the modifiers. We'll go to the X axis now and paste the modifiers. Look from above and we'll use value offset to bring it back to the center. And we'll put a phase offset of 1. Let's bring that back again. So if we now press play, what we should be getting is essentially that chain is moving in a circle. If you have a lot of weight on the chain, so you make your chain links heavier, and you don't have any other obstacles around, so I'll delete that cube and we'll lower this plane a bit, then you can obviously cause that chain to oscillate in the way that I had it. So another option is that you can put, as I did, you can make this end link also passive, and then the chain will just move around with that. If I just change that to passive, the chain will essentially just stay where it is at that end. And then depending on how fast this moves and how much give we allow with the connectors, the chain will just move around. So that's essentially just doing a little circular motion on the end there. One of the other things you can do with these connectors is you can allow them to be breakable. So in other words, if something moves too quickly, the link itself will break and it will no longer operate. And you can set a threshold here that has to be reached before it breaks. So let's just see what that's doing at the moment. At the moment, we've still got that passive at the other end. So we'll remove that and set this back to active. And if I press play now, our chain just drops down like that. So if I now select this object, and what I'm going to do now is I'm just going to rotate the chain. So I'm going to select it all, rotate X 90. So I'm going to keyframe the location, come up to say frame 25, then move it up a fair distance and keyframe that location. Now at the moment that's fine. It may be that that's not far enough, though that's quite a fun little animation in itself. I'm going to set this to interpolation mode linear and we'll go even further. My intention is to make this break. Again, there will be other ways of doing this. At the moment, the simulation is doing very well and keeping up, partly because I've got quite a short chain here. But let's go to this link now and make this breakable. You can now see that broke the link and the rest of the chain fell down. If we come back, you can see it starts to rise and then all collapses down, and you can obviously have a much longer chain than that. That's really all there is to making a simple chain with reasonably good constraints. So just a few final elements, and that's under the scene settings. So you come to the scene settings under rigid body world, open that up, and you have a few options here. You can obviously affect the speed of the simulation. Split impulse, really, just try, if you're having some bugs and things are breaking when they shouldn't, just try using split impulse, but it often doesn't solve the problem you're trying to solve. If you're finding things are passing through, such as they're falling through other objects that they shouldn't be, you can either increase the solver iterations, which will go up to 100, or you can increase the steps per second. Do this with caution because it will very significantly slow down the time to generate each frame. But of course, you only have to do that once. You don't have to do that during render. So you could just put it to whatever you want to put it and then do your calculation. But the other thing is you can introduce some instabilities by doing too many calculations as well. So do that with some caution. I used an actual step of 1,000 per second because I was using quite a lot of chains and therefore it's very easy for instability to creep in. But at the moment, with a small simulation like this, clearly 100 steps per second and 10 solver iterations, or in other words 10 calculations per iteration, is fine. And that's really all there is to creating a very simple and reasonably stable chain. But overall, don't forget, there is still quite a lot of instability in physics simulations. I don't think that's changed a great deal for some time. Hopefully there will be some improvements on that later. You can do things like, under the physics world, for each object, under dynamics, you can add a little bit of damping for translation, so that's movement and rotation. And if you're finding when the chain gets down to essentially where it should be still, and it continues to jiggle around, you can set a deactivation value. So what this basically means is when the velocity of an object, or its angular velocity, reaches a certain point, it will essentially be disabled. It will no longer respond to anything. So it will make it stop moving, essentially. So that stops the very fine little vibration jiggling that you can sometimes get with physics simulations. I didn't need to use that in mine, but nevertheless, it's there if you need to. And as I mentioned before, damping for translation and for rotation will also help make sure that the simulation comes to a halt. It has a natural value in there, but you can obviously increase that to make sure that the things rattling on terminate reasonably quickly. So I hope you found that useful. If you did, let me know, and I'll see you in the next tutorial. Thanks a lot. So I hope you found that interesting. If you did, let me know. If you enjoy these tutorials, don't forget to click like and subscribe. I also have a Facebook page and a Twitter account, and I now have a Patreon page as well, and I'll provide links to all of those in the description below. So I'll see you in the next tutorial. Thanks a lot.